Thanks everybody for coming. I'm going to start with a confession. Robin and Sriram are going to talk from kind of deep research knowledge. I'm a person who's, well, generalist. I've been in kind of administrative roles for decades, and that leaves you with a brain that's a mile wide and at best a few inches deep. But it does have a fair bit of interactions with the medical community, and lately I've been quite involved in ethics and computing instruction and other things, and that's had a lot of medical aspects as well. So I'm going to draw on that and just tee up 4 topics, each of them very briefly. The first of them, what impacts AI, particularly generative AI, are going to have on the workforce, and particularly the medical workforce. The second one, the amazing possibilities of AI coupled with medical databases, especially if we got better medical databases. The third one, amazing developments that have happened in the world of protein folding with AI. And then the most futuristic one, neural implants, and what that could actually mean for us even with brain privacy. So I'll get started, but I wanted to start with a little bit of a thank you. I've been in this community for most of my adult life, and I've been fortunate to be quite healthy. But as I've gotten older, maybe I should just say as I've gotten old, I've had more interactions with this community, and I really appreciate what you all do, and thank you very much. So, diving in. Are there any radiologists in the room? Okay, at least one. So weren't you supposed to be out of jobs by now? Yeah, that was the prediction that started being made almost 10 years ago. In fact, I think the most famous one was by a guy named Jeffrey Hinton, who's well known to all of us computer scientists. He's considered the godfather of deep learning. And in 2016, he said medical schools should stop training radiologists because computing will take over their jobs within 5 years. And it hasn't happened. It's not going to happen. And why? It's not that anybody was wrong about the ability of AI to read images very well and arguably better than physicians can. It's because there's so much more that radiologists do besides read images. For one thing, to talk to the patients whose images they've read, particularly when there's issues, and talk about treatment options and hopefully be empathetic. That's where you were getting to your silicon versus carbon. And also to confer with other physicians and many, many other things. And so in fact, going to have the sheet for a couple of quotes. There's a person named Jan LeCun who interestingly received jointly the Turing Award, that's the Nobel Prize of Computing, with Jeffrey Hinton. And he said, "I love and admire Jeff, but we knew then and we know now that he was wrong. AI is taking over radiology, albeit slowly, but he was wrong to say that we should stop training radiologists. AI is transforming the profession, not replacing it." And so that's really a lot of the discussion. And interestingly, the things that AI might be able to do more of will simply probably allow more patients to be seen by radiologists. And there's, the demand is there, so that's a good thing too. So I'm going to come back to that at the very end of the remarks and talk a little bit more generally about what AI and generative AI is doing to jobs, and particularly medical jobs. But I'll move from there to the second little one, which is about the power of medical databases, health databases, coupled with AI. And I'm going to quote a friend. This is a guy who's now the Dean Emeritus of the medical school at the University of Virginia. And he said to me about 10 years ago, you know, I can fly halfway around the world, put my credit card in an ATM, and it gives me money. But if I just walk across the street from the doctor's office I've been going to a new one, they don't know anything about it. And that's true for the most part, but it may be changing. And to the extent that that changes, to the extent that we have medical health databases that are more complete than that, the possibilities coupled with AI are really impressive. You know, as one example, one of the hardest things to cope with are drug interactions, particularly drug interactions coupled with various medical conditions. And if you have a vast database, you can look into it and say, do you have instances of somebody who's taking drug A and drug B and has condition C and condition D, and see what sorts of experiences they've had. And you can do far more of that than anybody's going to have from their own personal experience and that of their colleagues in their life. Or another one, if you have a lifelong history, or even a decade-long history, of every medical test that somebody's taken, every blood draw, everything else, And then you can compare that to a database of other people and see how various symptoms may be progressing. What is this saying about the progression towards diabetes or dementia or so many other things? You can do far more than a human is capable of. A human is not capable of processing as much data as an AI program is. So this is one of the ones where I think it's mainly upside. Of course, first of all, there's huge issues in getting there, in getting that sort of a health database. There are places that do more of this. Israel has had a more or less nationwide health database for a long time, and it does some of these things. And then, of course, there's all sorts of privacy concerns that patients have. So there's plenty to this, but there is potential. So that's one. As I said, I'm just queuing things up rather quickly. The third one I want to queue up is the area of protein folding. Interestingly, this is the one of these topics that I have some research experience myself. I don't know how familiar you are with that term, but it simply refers to going from the sequence of amino acids that define any given protein to what its physical three-dimensional shape is. And of course, that three-dimensional shape is absolutely crucial to understanding how that protein will interact with other molecules, what molecules can dock with what other molecules. And this has been a really difficult problem for decades. Historically, this was done experimentally in the laboratory using things like X-ray crystallography or NMR spectroscopy. And then about 20, 30 years ago, groups, and I was in one of these, started trying to do this computationally, and it was almost pitifully bad. I mean, you could get partway there part of the time, basically. And then about 3 years ago, a system called AlphaFold 2 that comes out of a company called DeepMind, which is a Google spin-off, basically, essentially blew the entire problem out of the water. They were able to correctly, computationally, predict the structure of almost all of the 200 million known proteins. I think the implications of this are just starting to be known. I don't think there's a downside to this one. Every other topic I'm mentioning have ups and downs. This one is probably entirely an up, and I think we'll get to see what impacts this has on drug design as we move forward. The final one is still the most futuristic, the idea of brain or neural implants. I think you all get to hear about this. Our friend Elon Musk is part of the reason we all get to hear about this. And actually, coincidentally, just in the last couple of days, Neuralink, the Musk company that does this, implanted its first implant in a human being. But other experiments have been doing this for a number of years by now, and there have been some spectacular successes. Now, at this point, these successes come from millions of dollars, couple of years, countless time for a single patient. But still, what have they done? There have been cases where patients who've been had strokes and not been able to speak for a couple of decades, they were able to put in implants, train them through AI to pick up what that person is thinking they want to say, and actually train it to do that fairly accurately, and then that output initially was coming onto computer screens, more recently onto voice synthesizers. And within the last year, at about half of the rate of normal human speech, and that's only going to get better. Another one, the ones that I find even more remarkable are people with spinal cord injuries, people who are paralyzed. They put in implants that in the region of the brain where they translate the thoughts that are trying to produce movement. And then a second set of implants lower down in the spinal cord. So you're essentially electronically bypassing the spinal cord. And in one case also a third set of implants in the appendages, in the arms in this case. And they've been able to get a patient to walk fairly naturally, not entirely, but fairly, using these thoughts, the AI, and these implants. And we'll see where this goes, but the possibilities are amazing, and it's the AI translating the thoughts that is responsible or necessary to do this. But that leaves everybody to worry about, are we getting to an age where, you can drive by somebody's house, and if they have Wi-Fi and they don't have it secured, you can tap into their Wi-Fi? Are we one day going to be able to do the same thing to people's thoughts? And that, of course, would violate, the most sacrosanct privacy that we know, the privacy of our own thoughts. I mean, I'd be able to stand here and say, hear one of you saying, when is that idiot going to get off the stage? So, whether that's ever going to happen or not, not that idiot get off the stage part, but somebody's thoughts, we'll have to see, but it is something that people worry about. So finally, circling back to the impacts of generative AI on the workforce. Just in these last 15 or so months that generative AI has really been out there, there have been a bunch of studies. A couple that come to mind, there was one done by OpenAI in the University of Pennsylvania that estimated that 80% of the jobs in the US could be done and have at least 10% of that job done by generative AI. There was another study, I think this was by Goldman Sachs, that estimated that about 300 million jobs in the world might be replaced by generative AI. That's about 10% of the jobs in the world. None of this is new. We've had transformations forever, basically. The transformation from farm to factory, the transformation from factory to office, the transformations that computing has caused even before this. But there are two things that are very different. One is the speed. That first transformation took 2 centuries. This one, your 15 years is about right. We probably got 10 or 15 years to work our way through this transformation. The other one is that this is the first transformation that is impacting more than basically physical jobs. In fact, there's a quote by a leading labor economist at Stanford, his name is Eric Bjornofsson, who said, "It surprised most people, including me. To be brutally honest, we had a hierarchy of things that technology could do, and we felt comfortable saying things like creative work, professional work, emotional intelligence would be hard for machines to ever do. Now that's all been upended." You might still argue with a little bit of that, but that is part of what we're seeing. So what is that going to do to the medical profession? I don't know any better, but I think some of the prospects are actually quite encouraging, because there are things that any physician or most physicians spend too much time on now, post visits or during visits, basically recording everything that's gone on, making notes, documenting those visits. That can be automated to a decent extent through AI. By having the audio part that's actually listening, by generating through generative AI, and then checking, we might be able to free up what a lot of physicians will say is the least fulfilling parts of their jobs right now, and free up people either to spend more time with patients or to spend time with more patients, depending on how that works. So I'm relatively optimistic. I think we're also going to see AI programs that people use as partners to tap some of those databases and kind of couple the intuition that everybody has and the knowledge people have working with humans with some of that big data prediction. So hopefully this is more of a plus than a minus for this profession. That's not true for all other professions. And I'll stop there, and I'm sure there'll be plenty to discuss if people want to discuss that one.
All right. So I want to start by telling the biomedical engineering students down there that my PhD was in biomedical engineering, and I still remember my capstone project. And it was to work with a company that did prosthetics, and we built a platform for building accordion keyboards for those that had fewer than 10 fingers to still be allowed to be able to type everything on a standard keyboard. I don't know if they went anywhere, but it was fun. So now, and pretty much since I graduated from my bachelor's, I've been working more in the genome space, originally working at WashU on the Human Genome Project as it was being sequenced, and doing some of the early analysis on it. And some of you may remember the press that happened with the Human Genome Project. NIH funded this multi-million-dollar project because if we sequence the human genome, we could, and I swear I've seen this in print, solve medicine. Did it work? It was argued when the Human Genome Project was started. It was argued again when the first finished genome was published in 2001, and then when the second finished genome was published in 2004. first one was largely political, the second one was actually closer to done, that medicine would be revolutionized in 5 to 10 years. That's now been 20 years ago. And we're still lagging, I think, in what some of those early prospects suggested. That's not to say we haven't learned a ton. And a lot of the genomics impact on medicine has been in subtler ways than I think those original forecasts suggested they might be. But I want to talk about, I have my own list of 3 or 4, and they surprisingly are overlapping with some of Bobby's. There have been a small number of changes in the last couple of years that I think are really shifting genomics and its ability to change medicine. Before I go any further though, I have to laugh that he wanted us to talk about how medicine is changing and none of us are MDs. So what are those 3 or 4 major shifts? The first one is data. When we were sequencing the human genome, we thought about it as like cracking a code, like a Rosetta Stone, a different language. And while there is something to that analogy, there's also a lot more complexity to biology than we were perhaps naively aware of. And so in order to understand that complexity, we have to be able to more finely measure what's going on. And we've transformed a lot of technologies for measuring what our cells are doing, how they communicate to each other, all of those sorts of things. But it really hasn't been, except in the last few years, that we've started to tie genomes to medical records, even though that seems quite intuitive to me. I'm going to argue that probably in the next few years, and I've seen a little glimpse of this, that the other thing we need to tie to those genome records to really understand them is environmental exposures. Because we're not just our genome. We're also what we've been exposed to, what we've done in our lives, our experiences. And the one example I have of this is a really cool project. It's actually by one of my colleagues in CS, where they're looking at COPD, and they're looking at exposure of individual people to various pollutions in the air, and they infer that from environmental data and your street address. And then they link that to your medical records. And that's kind of a new way of thinking about how I might get your history other than just asking you all those same questions when you first go into the doctor's office. So more data is absolutely necessary to understand the genome. Number 2, we have not done a good job as genomics people in explaining what we do know about the genome. And so, yes, I can go get my genome sequenced for $100. And that might say I have some mutation in some CDKN1A gene, but then when that gets transferred to the doctor looks at it and either they have to have a PhD in genomics, or they're just like, I don't know what that means. So there's been a real push, and there's another of my colleagues at the medical school that are kind of leading this push, at changing the way doctors interface with genomic information so that it's less centric about gene names and locations in the genome, which mean very little to patient health, and turning that into actionable items. Okay, if this person has this mutation, what could I potentially do medically with that? And so the name of the gene no longer matters, just the link to what does that do for my practice. So that's more of a human interface kind of thing, but it's a specialized interface for the medical profession. The third is what I'd call the democratization of medicine. And this is things like the increased access through telemedicine, but also things like wearable devices, right? I know how well I sleep every night. I mean, I wake up and I kind of think I know, but it turns out this thing's far more accurately at telling me how good my day's gonna be than my own perception of how to wake up in the morning. My father's a type 2 diabetic. He wears a wearable diabetes monitor. When you're at his house and his phone starts beeping from across the room, you have to go find him because his blood sugar is getting way too low. Right? Those kinds of devices are giving us a finer grained readout on data, so this links back to the first one. But it also is now allowing people to have more control over what they know about their own health. And that has to improve the direction of where medicine is going. I think I had a fourth one, but I don't remember. So I'm going to stop it at those 3. If I remember later, we'll have some of it finished.
Sorry, my voice after all day talking to students, I'm Probably not going to keep up a voice for too long, but 10 minutes, right? Okay. So my area of research, my name is Sriram Sankaranarayanan. I promised I would pronounce my own name, so there it is. I've been a professor in computer science for the last 15 years, and my area of research is in safety of computer systems and these days in autonomous systems, and I study autonomy. And autonomy it's a word, it comes from Greek, I guess. Auto means like self-governing. So these are systems that try to make their own decisions without much human interaction. So it's an ideal world where we want to deploy systems that like self-driving cars. You don't want a driver behind the wheel. You want the cars to make their own decisions on how to navigate through traffic and take you from A to B. Or airplanes are quite autonomous. You do need a pilot, but only to make sure that 1% of the time when things don't go well, there is someone behind the cockpit to land the plane. So you do need the pilot to land the plane these days, but it mostly flies itself. And I've been looking into medicine as well. So there is applications of autonomy to medicine. So one very prominent one I've been working with, any endocrinologists here? So you should know about the artificial pancreas. So for example, so I started looking into the artificial pancreas about 10 years ago with people in our medical school in the Barbara Davis Center over in the Anschutz Medical Campus. And I was really interested in the safety of these devices. So what's an artificial pancreas? It's kind of a fancy name for an insulin delivery device. So people have had insulin pumps that deliver insulin. And these are programmable. You can punch in some numbers and it delivers a basal insulin and a bolus insulin. And people have had increasingly good sensors. So you talked about a sensor like a Dexcom G6, which is a really, really good sensor. And it just goes under the skin, gives you rather accurate blood glucose readings. So what people had thought about was, here's a sensor which reads blood glucose. Here's a device that can give insulin. Why don't we close the loop and have a program that simply tells, is your blood glucose level too high? Well, let me increase the insulin. Is it too low? Let me decrease the insulin. And in our world, that's called automation. That's like your cruise control, trying to make sure that if your car's going too fast, it's going to brake. If it's going to go too slow, it's going to accelerate. But that was just the start of things. And even that little advance took about 15 years of research by engineers, by clinicians, and lots of clinical studies before FDA approved it. I think 2019, the first device came out, Medtronic 670G. Now there are more devices that are coming out. But the interesting thing is these devices are getting way more sophisticated now. And what they are trying to do is they are now trying to work with people to manage their blood glucose levels. So we have an NIH project going on, again with people in the Anschutz Medical Campus. And we are trying to understand the context behind someone's life, because blood glucose level control depends on food intake and depends on exercise, depends on human behavior. And it's very difficult for an AI to predict human behavior. And so what we are trying to do is looking at patterns of behavior and trying to say, hey, are you going to eat dinner in the next half an hour? And if so, maybe I can start to bolus insulin or raise the level of insulin, hoping that you're going to eat. But then I study safety. So the safety side of this question is very critical because too much insulin means that a person's just going to die. And this has happened. Insulin pumps, for example, that have not been set in the night when people go hypoglycemic and the pump doesn't turn off, means that we've had fatalities. People have died because of overdose of insulin. And so this is a very dangerous device. The amount of insulin you can give, more insulin you can give a person and still hope for them not to have a serious seizure or anything more than that is very low. I mean, so how do you make sure that these devices are safe, and how do you make sure that the AI is going to do the appropriate thing? And I've found in the last 10 years that it's almost impossible without human intervention. And the reason it's impossible is just like everything else, context matters a lot. So for example, you might recognize that a patient eats every day at 12 o'clock. And so they are eating every day at 12 o'clock. So at 11:30, you decide, okay, they are going to eat at 12 o'clock. So the device decides to bolus. Give them a bolus of insulin. And then that particular day at 12, they are going to eat lunch, and then someone just stops them and says, hey, what's going on? And so they are chatting with them until 12:20, and then something else happens, and it's 12:45, they've had a big bolus of insulin, they haven't eaten, and that's the day when your AI causes something serious, causes a hypoglycemia incident. So this is one of the reasons why I'm not too sure that AI can replace human intervention or autonomy will be successful, because context is very, very, very important. And without context, you end up making all kinds of assumptions, and AI makes it as well as humans do, or even worse than humans do. And as a result, you get crazy things. Like, for example, here's another example. I had a PhD student, Taisa, who worked on this topic with me. And our goal was to build a machine learning system that takes in data from a patient, blood glucose level data and insulin data, and predicts maybe 60 minutes out, 2 hours out, 3 hours out, what is their blood glucose level going to be. So rather than having a real-time warning about someone being hypoglycemic, we could try and give an advance warning. Maybe 1 hour ahead, we could say, hey, you're going to go hypoglycemic. And that would be so much more useful. It would reduce the amount of carbs they need to consume, for example. And so we built this machine learning system based on data from our collaborators. We had lots of data. We built this system. It worked really well on that data. So what that means is, on that data, it managed to predict blood glucose levels 2 hours out, 3 hours out to plus minus 30 mg per dl, which is really good. We were very surprised. But then when we looked closer at that result, we actually saw that the machine learning model had actually learned very counterintuitive things. It's always difficult to say what goes on inside a machine learning model. These are black boxes. Opening them is very difficult, but part of my research is about understanding what goes on inside these black boxes. So we tried, and we found that the system had learned a counterintuitive fact that when you give someone insulin, the system thinks that their blood glucose level goes up. And yet it managed to predict their blood glucose levels correctly. And this was a puzzle until I understood, why would someone take a bolus of insulin? Well, they would always take it with a meal. The meal causes the blood glucose levels to go up, but the AI thinks that the insulin causes it to go up. And as a result, you have a system that's learned something wrong. Rely on the system for advice, it's going to give you very bad advice. It's going to tell you, if you have low blood glucose level, inject yourself with a ton of insulin. Now, this is just experimental, but you can imagine we are just scratching the surface on all the things that lie under the hood. So we talked about radiology, we talked about AI being able to identify features in images for radiologists. But we also know that these image recognition, these classifiers are extremely fragile. So for example, in the world of self-driving cars, there's a very famous research project where they took these stop signs, and a self-driving car needs to be able to identify stop signs. They just took 2 little black stickers and just stuck them at strategic places, and suddenly the AI thought that the stop sign with these 2 little black dots on them was a 60 mile per hour speed limit sign. And these kinds of issues are called adversarial attacks on images, and these are very, very common. You take an image, you flip a few pixels, and then it's completely easy to fool an artificial intelligence system. And there are fundamental reasons to believe that these kinds of things can be improved, but can never ever be completely conquered. There are fundamental reasons to do that. So where this all goes to show is my research has led me to believe that you can never take humans out of the loop. Even when it comes to piloting a plane, I talk to real pilots and I tell them, is your plane flying itself? Could you, just get off the plane and it will fly safely from A to B? And they laugh at me. They tell me how every hour it has about 20 or 30 incidents where it hands control back to the pilot who has to pilot the plane. So you may think that these systems are great, but these systems have their problems. And medicine tends to be messy. I'm married to a doctor, so I see her at a distance, but I know enough to know that the real world that medicine works in is messy. So when you hear ChatGPT is getting 90% on USMLE step 1, then you think about how much of USMLE step 1 do you need for your day-to-day work. You would know that that is not impressive at all. So when I told my wife, hey, my ChatGPT that my people have created, from the Silicon Valley, can beat USMLE, like beat you guys on USMLE step, but she just laughs. She's like, sure, they can do all of that, right? My textbook can beat me on USMLE step 1. That doesn't mean my textbook is a better doctor than me, right? So sometimes, when you look at this hype, you have to really imagine, can AI really work in the messy world, real world, right? I think it cannot. In the ultimate analysis, safety is going to be a big issue. People do not want to put their lives in danger. Even something that's 90% good means that it's 10% bad. And you try to tell that to a person whose cancer got missed by the AI, right? Who had to wait 6 more months before their cancer got caught and went from stage 4 to stage 5. And that happened to me, to my cousin, sorry. And so it's a tragedy when these things happen. And so in medicine, these things happen a lot. So I don't know that AI will ever be able to replace doctors. And like Bobby said, AI is going to take over a lot of interesting things that you find cumbersome, like charting, like being able to do better care coordination. I think AI can help with that. Being a co-pilot, being able to look over your shoulder when you make medical decisions, being able to do prediction by assimilating lots and lots of data. So all the data from your patient's cell phones, from their devices, could all go up in the cloud and you could get a nice digest. But in the end, I don't think patients are going to want to talk to a computer. I think most patients want to talk to a human, and most patients trust human judgment. The other thing AI can't do is read your facial language. Think about if you're a pediatrician, then the dynamic between the parent and the child. Those are too complicated for AI to understand. So my sense is it will change the practice of medicine, but it's not going to replace doctors. And in fact, I think it's going to be more of a nuisance in many cases, and you really are going to have to deal with patients who get misinformation from an online chatbot that they talk to that just told them they have stage 4 cancer. So you're going to get a lot of that, and that's going to be a problem, right? So there's going to be all kinds of misinformation. You're going to have to deal with insurance getting these hands on these AI tools, and they will do a lot of mischief. They will second guess you, they will deny the medication that you prescribed because their AI is telling them that you could do something different. So that's going to be there. The headaches are going to be there. Some of them are going to be there. Some of them are going to get better. But I think it's going to be like electronic medical records. So it's going to be the next stage in evolution, but never really going to replace the physician. I'm willing to bet my house on that. So thank you so much.
Okay, so question time. I only have one piece of paper with a question on it. So if you have questions, write them down. Louise can raise your hand. Louise can run around and pick them up. Okay. You must have some questions about this. So the first question that came up was about the black box. Because for silicon, we'll call it silicon, there's input, and there's output, and then there's processes in between. Right? And it seems like the computer science world is losing control over what happens in between. And so can you comment on that and how it could, you mentioned some instances where it could spiral out of control, you have false outputs, and but any comments on that whole process? Because that seems to be accelerating with the whole hallucinations and all the other things we talked about.
I guess I'll start. There's probably 2 different aspects of that you just hinted at. The hallucinations in generative AI are just about getting some things wrong. And we can say more about that. But I think the one that Sriram's comments got at, and mine could have as well, is that a lot of the things that you hear about in AI are using these deep neural nets. And these are, well, ChatGPT is what? 4 is a trillion or 2 trillion parameters roughly. So these are enormous things. And just to give a trivial example, if you have something that's trying to recognize, is this a dog or a cat, and you're going through a deep neural net trying to do that, conceptually you would hope that, oh, now this is the stage where it kind of looked at the eyes and got something, and this is the stage where it looked at the fur, and this is the stage it did that. That's not how these things work, or at least that's not what we're able to extract from them. They have they get input, they get trained over trillions or millions or billions or whatever parameters, and they have an output. But we don't have a kind of a sense of what they learn along the stages that replicate the way we think that humans break up these problems. And so we don't have the explainability. And this is the whole topic of explainable AI. And I think with that, I'm going to hand the mic to Sriram, who knows this topic way better than I do, to say a little bit more about it.
So partly this is historical. When I started my PhD work in AI, I belonged to a different camp. We were the symbolic AI people. And we were thinking AI would kind of be very rational. It would crunch symbols and work through problems the way we would work through problems. A mathematician would work through problems. And then there was the other camp, the connectionist camp, working with neural networks. And they beat us, like black and blue, right? So we have, people like me are now trying to see, so that's why I get some pleasure out of seeing connectionist AI, neural networks fail, because then I can say, I told you so, right? But frankly, I think what's coming up is we are trying to integrate, we are trying to make these systems reason more about humans and be more explicit about what they are thinking. Right now, we have no understanding of what goes on inside the black box. And the kind of techniques I use in my work are for very small black boxes. Compared to that, you're talking about me being able to take a very small network and tell you what it does. And ChatGPT is at least 1 billion times bigger than what I can do. So it's very difficult to understand what's going on inside these networks. And we don't have that level of mathematics or the level of scientific understanding of these things. But the hope is one day we would, but in the meantime, we have to be careful what these things tell us.
So I'll just give you an example. So what they mean by explainable AI is that many of these systems essentially detect patterns. And sometimes they're mathematical patterns, but what does that mean to a human is really hard to say. So there's a famous AI case, and these guys may start shaking their head yes. A few years back, where a group trained on pictures and claimed that they had an AI system that can predict whether you were going to end up in prison based on just a facial picture. And of course, that was a very controversial paper and a very controversial system. And so they started really picking apart what was it that the AI was detecting in these pictures. Well, the AI had been trained on mugshots. And then the AI had been trained as their non-criminals on straightforward photos that they had gotten off the net of people. And so it doesn't take a lot of thought to realize that nobody smiles in a mugshot. And so it turns out that if you're frowning, you're going to prison. But it was actually really, really hard to figure that out, because it would tell you there's like this little math around all these parts of your face, and it was like, oh, that's just frowning. Right? And that's what is meant by this disconnect between what the pattern learns and how do you interpret it as a human.
Along those lines, there's a question, and are there any movement patterns and predictive injuries and predictive injury patterns that currently in the works that you know?
Yeah, there's a whole area where people are looking at human gait. Robotics, for example, people in robotics do that. So they are looking at how people walk, and part of it is also to understand human walking, bipedal walking, which is very difficult for computers to do. It's It's very recently that they managed to build robots that could walk on 2 legs, and they don't walk like people do. And so now they are looking at all these gait changes from different kinds of, I'm not an expert here, but people are looking at, different gaits, how gaits change, how people walk differently. They are also looking at prosthetics. They're called smart prosthetics. So they are prosthetics with actuation in them, so they can generate force and help people get better balance. So all of that's happening, and it involves, AI, machine learning has really brought that field forward, like overnight, because of all these new machine learning advances we made. So for sure, yes.
Cut to the chase. How do you sue AI? Who holds the responsibility? A lot of the large, the ChatGPT and everything else. They now control a lot of these big databases,
Right.
and that seems to be the name of the game. Is data is power. So just looking into the future now, how could that influence healthcare, and they can start to nudge doctors and patients, like you were saying. They already come to my clinic and they say, I counseled or I consulted with Dr. Google, and he says that, I have this, that, and the other thing. It's like, well, not really. So what would, from your perspective, being on the computer science world and the tech side, more on the silicon side, and you've got a room full of carbon, and the lawyers are the ones that, are part of healthcare as well. What do we expect that to develop into?
I'm just going to mainly say something whimsical and then hand it to Sriram for the real insight. How do you sue AI? You call yourself the New York Times. Because the New York Times is one of the first major lawsuits against OpenAI, ChatGPT. Now that's for something different. That's for intellectual property. That's one of the big things there. But you were talking at dinner, and so I'm going to pass this over to you about before this started being looked at probably as much in the medical world. There's already been quite a bit of thought of it in the autonomous vehicle world, because it's an entirely different thing. Up until now, the liabilities are with the driver. So if you're in an autonomous vehicle and there are accidents, where are the liabilities? And that's starting to be explored and starting to be thought through. And not only is it difficult, but depending on how it works out, it could be the death of the autonomous vehicle industry. But you were talking about that, Sriram, so I'm going to pass it over to you to say more.
I think this is where the lawmakers haven't weighed in yet. There's no laws, and frankly, many states are getting it wrong. So they are, indemnifying companies that make these products from responsibility for what they do on the road for self-driving cars. I think with medicine, I'm hoping it will be different, and I think it will be because everyone goes to a doctor, and everyone is invested in the doctor giving them a diagnosis and saying, hey, what you have is this and not that, and that's very important for our society. And so self-driving cars, there's been more of a sense, these are just toys. There's a few on the road. What harm can they do until they go hit a pedestrian? But with medicine, I think this is where advocacy is going to matter. Ultimately, I think that in an ideal world, any decision that AI makes has to be just a suggestion, and it has to be a doctor who has to sign off on that decision. If an AI identifies something in an MRI and says this is a problem, it has to be a radiologist who signs off and says, hey, this is really a problem, before they go and do an expensive biopsy or cause some other problems, right? So I feel like this is going to be the way things will happen, and American Medical Association is very powerful in many ways. So I suspect it will be the case that there will be a doctor still with their license that is going to have to certify and sign off on all the decisions. Ultimately, it has to come down to that, or else I don't think any company will be able to take the liability.
I'm just going to throw in one more little thing, and then I'm always the optimist in these conversations. One of the things that has plagued the technology world is that the people who legislate have very little understanding of technology, and they're always behind and always don't understand it. The medical side is slightly better that way. There tend to be a few physicians in Congress at any given time, as opposed to no engineers usually. And anybody who's in Congress, especially as they age, has plenty of experience with medical care, whereas they usually have very little experience with technology. So hopefully it'll be a little better. That is the regulating of the medical side versus the technology side.
So, should AI be regulated?
Yes.
Yeah.
And how? Because, there's an AI race globally, it seems. And there's a concept of if we don't keep going, then we're going to lose. And the winner takes all, it seems, in this kind of global AI race. What is the talk in the computer science world about that?
Well, I'll just start with one aspect of that, and then I want to pass it on, and that is that this is a global conversation, not a US conversation. And that gets really interesting because in all of this technological regulation, you have very different worlds in Europe than you do in the US, and then to some extent in other parts of the world. And as you may be aware, the European Union is far more on the privacy side in everything and on the regulation side than the United States has been. And these are all global companies, global products, and global issues. So it's making it a very complex situation, and to some extent, the European Union, which is both more stringent and quicker, is tending to set the tone for the rest. And with that, I'll pass it.
Not touching that one?
Not touching that.
I think AI should be regulated when I think it's more akin to what OpenAI did in releasing ChatGPT. I know it has its defenders. I think it's like releasing the nuclear bomb. For me, it was a big nuisance that semester because it basically could solve all the assignments that I gave to my students in my programming class. And I found that the students were doing very poorly in the exams. So it basically made sure that a bunch of students that semester who were using it without any guidance from me lost a bunch of grades. So that semester it was a nuisance. I was very annoyed with them. But then I do think in the long term though it has to be regulated because there's a lot of harm that could come from letting AI do things. So for example, we talk about actuation. So currently ChatGPT does not have the ability to turn on the light switch or turn off the light switch in your home. It does not have the ability to hire you. So for example, it could try to hire you through Amazon's Mechanical Turk. It could have a contract, it could try and hire a person. So when you start to give AI the knobs to control things like in your power system or in a medical device, like there have been suggestions for having control of artificial pancreas devices from the cloud. So people could come in and control your insulin pump or your car. So when ChatGPT gets the power to do those things, some really bad things can happen. And right now, those have not happened, but regulation needs to start happening, saying this is the extent to which we allow ChatGPT. The other thing is child safety. There was a big debate about that. That's actually really bad because children are getting their hands on these tools and they are not meant, they are not child safe, they are not protected. They are going to really expose children to very horrible things. And you can say that the internet does that, but AI can just do it in the course of a conversation. So there is some, for example, another thing is you can make this chatbots. Interestingly, the very first AI chatbot was called Eliza back in the 1970s, and it's very simple. It's supposed to be mimic a psychologist or like talking to you. But these ChatGPT, if you start to manage to sell them as here is a product which will talk to you just like your psychiatrist does. Well, it can cause real harm to a person, let's say who has suicidal ideation. Do you want them talking to ChatGPT and then something that ChatGPT tells them sets them off, right? I think there's real danger here. So you want to put those guardrails and say, these are the things AI can do and these are the things AI cannot do. and that cannot part, a lot of it intersects with medicine. So I feel like the regulation needs to be there. And I also share Bobby's opinion that our Congress doesn't know how to regulate this. It's relying on Silicon Valley, and even though they are my people, they are not the right people to be saying this. They like hype, and they just don't, the hype is too much. So I will say something.
I would argue that technology in general, there's an ecology of technology and an evolution of it, and regulation is either forward-looking or reactive, and most of the US regulation is reactive. And so the reality with AI is people are going to have to probably die. And that's kind of grim, but realistic. The thing that came to mind listening to Sriram talk is seatbelts, right? Cars were a life-changing technology, but the introduction of seatbelts, it was really initially driven by some safety folks, but then by public push on the idea that a car with a seatbelt, because everybody watched the crash test dummies go through the windshield on the commercials, right? That was somehow a better product. And now we're in an era where you can't take your child home from the hospital without a 5-point harness that's been properly installed and safety inspected. Those all come from reactive policy.
So along those lines, if doctors, if the AMA went to Congress and said, we would like this, what would each of you recommend as a statement to Congress to enact for regulation, for healthcare, being carbon types? Yeah, tough question.
I can start with one, and then so the first thing I would recommend is protecting the epic medical records from people who would want to mine it to then steal your medical decisions from the past. The second thing I would really do is have some kind of protection from AI getting its hands on like insurance, how insurance gets to use AI, because they see a lot of the medical decisions that you make, and then they tend to then start second guessing. And so those would be 1 and 2. Then the 3 would be like things like AI talking to children, AI talking to people with mental health issues. I think those are dangerous areas to venture into, right? AI prescribing medicine. So maybe a US company will not do this for liability, but maybe a Chinese company or a company somewhere in some island deploys a chatbot that pretends to be a doctor and starts prescribing stuff. I think those are things where AMA can really say, keep AI off medical advice, leave it to professionals. Let AI be in the back end where the physician looks at AI, but let's not make it patient-facing in a realistic manner, right? So I think those are places I would start with, but I don't think that will happen. But still, it's my wish list that there are some people who shouldn't get to use AI.
I'll just make 2 quick comments on that. One, a plus. I suspect that if AMA believed it itself and could get Congress to somehow encourage more of a global medical record in this country, that there are a lot of positives that could come out of that. And so that would be a positive. Just going to comment, we are talking about AMA, that is, it's for this country. And I agree with what Sriram's saying about AI not replacing physicians, but we do have to remember that when we start talking about the rest of the world, that there are a lot of places in the world that you're talking more about the difference between people in remote, poor, rural areas having some access to healthcare, even though a fair bit of it is AI, versus none at all. And that becomes a very different conversation.
Yeah, there's a follow-up question for you, Sriram, for the panel really, but since you were taking the lead on this, that's okay. Who decides what populations are wrong? You mentioned children and the maybe mental health issues, elderly, TBI, traumatic brain injury patients, so people who maybe don't have the decision-making power.
Yeah.
Where's the rationality, the decision for it's a mature decision to apply AI?
I mean, I'm not saying AI should never be applied, but I think there should be a standard, just the same standard you apply for clinical drug testing should be applied to these kinds of interventions as well. And again, FDA is behind it in terms of how it considers medical devices versus drugs, and I don't know where it's going to put AI in this mix, right? So with AI dispensing advice, well, maybe it's good advice, maybe it's things that the medical community is comfortable with, but that means that the consensus has to be there. It has to be, people have to study it, people have to do that before it's deployed. My fear is what's going to happen is people are going to, these chatbots are getting democratized. So people are going to do it as a whim, and then suddenly release it to the public, and suddenly you have this psychiatrist thing that's going to be online and start to give advice, and that's my fear, right? When these things are not tested. In that sense, I feel like legislation should stop them until there is some testing done. But I don't know if that's going to happen, but that would be my preference.
Yeah. Maybe the final question, or maybe second to last question. In preparing for this evening, I came across the term augmented intelligence versus artificial intelligence, and I kind of like that idea, because it really, what you're implying is that it'll be like all tech. It's a tool to make us more efficient, maybe make better decisions, et cetera, make life a little bit better. So the augmentation of the tech world might be helpful for our careers, but it's not going to replace, at least for the next 5 years, the intelligence in this room, hopefully. The question is, what two ways, do each of you have to comment on this, would you recommend clinicians to harness the power of AI in the clinical practice in the next 2 to 5 years? From what you know of the capabilities now, and how can we enhance our clinical care?
So I don't know about two, but I can do one pretty quickly, and that is one of the things that ChatGPT can do pretty quickly is give you background on reading on something that you're less familiar with. And so going from the genome's perspective, when people are looking at particularly, so genome sequencing is really good at diagnosing children that have an undiagnosable disease up to that point, or new mutations. But then you get some gene name that their physician knows nothing about. Their physician can take that to a ChatGPT system and sort of become a little micro expert pretty quickly, or at least know where to refer them to. And that's one place that seems like it would have a big impact quickly.
I would agree. So this morning I read a New York Times article about a search engine called Perplexity. I don't know if you've tried it. So I tried it this morning because I was doing some research and I was trying to fish a paper that I had read 15 years ago, and I just remembered a few things in that research paper. So I used Google, and I was very frustrated. It was bringing up all kinds of papers I wasn't interested in. I went to Perplexity, and it had this interesting academic search. So I turned on the academic search, and it brought up the paper quite quickly. So I was impressed. I think when in medicine you do a lot of research. I mean, you have to look things up from time to time, and these kinds of tools make life easier. The other thing I've been using AI to do is writing academic references, so which is something we do a lot in my job, and it takes me like for a PhD student of mine applying for academic positions, it takes me an entire afternoon to craft a careful 3-page letter telling them what they have done, and I found I could do it like in 1/3 of the time using ChatGPT, and if I did some hard work on the back end, editing it and making sure it is in my voice, I found that I could write a very good 3-page letter that really summarizes the student's work and puts it in perspective. And it would have taken me a long time to write that letter. So it is a time saver. I've been using it for my programming. So I've been just, I no longer read books on programming. I just type what I need done, and then it gives me snippets. That doesn't mean it's going to replace me as a programmer. It just makes me so much faster. It just streamlines my work in like so many ways that I find it a blessing sometimes that it's there. But that's the good part of it. So I've just started using it in many different ways. It draws pictures for me for my NSF proposals, though there's some rules that I'm violating with that. But but it's getting to be a good tool for working with me on a day-to-day basis, and I've just been enjoying using it.
Well, to the extent that I'm capable of original thought, I'm definitely not capable of it at 8:30 at night, so I'm just going to more or less reiterate two things that I hit on before. And one is what Sriram was saying. I think it's worth people thinking about what are the parts of the jobs, of the physician's job, that aren't about being a medical professional, but are other things you have to do that this technology could help with, especially as you were saying, even if it's essentially your first draft, but your first draft is taking 80 or 90% of the time away from that part of the job. So that's one, that's the mundane side. The other is, I was just reading something in the last couple of days about, what's the amount of data that a human brain really can process? And it's far, far less than what an AI can process, which is almost infinite. So there are ways that you can partner with something. AI can have read more articles than you'll ever read in a lifetime, or process more health data points than you can. So using it as a partner in places where it simply can consume more volume of information than you can, and partnering that way.
Good job. One last question. There was one question here that says, physicians are fallible too. At one point, is AI going to be more accurate, more predictively positive than humans? And that's impossible to predict. So I'm going to pass on that. But they're making a crux point where it switches, a transitional point, perhaps. You still need the human interaction, and you need to talk to people, and then notice the little twitches in the eye when you talk about something. You realize you hate your job, and you say, "Let's talk about that." But that being said, let me.
I'm just going to jump in and say very quickly. One kind of the highest order conversation in the tech world is when we're going to get the super intelligent form of AI. And so, if you want to have a different meeting of the society, we can talk about that one.
Okay.
I would say from my experience, humans are fallible, but machines are fallible in different ways. And the best case is when humans and machines kind of work together. But having said that, that's a hard design problem to solve, and engineers haven't quite done a great job of doing that. But if it can be done, I think that would be a win-win, because the kind of mistakes that AI makes that I talk about are never mistakes that a human would make, and vice versa. Often humans get tired, AI doesn't get tired. So I feel like there's a synergy there, but it needs to be employed in the right way, and so the conversation needs to move to that, I think.
I agree with this guys.
Okay, last question then. Each of you, in 2037, you go to the doctor yourself. What would be the ideal experience for that clinic visit?
Okay, so my cousin's an NP, and the horror that she was explaining at Christmas is that she gets 15 minutes with each patient. So the ideal scenario would be that it's not set at 15 minutes.
But the idea is, no, but if you could imagine, if you had a magic wand and you could create the perfect experience, what would that be before, during, and after the visit?
I personally get irritated when I go to the doctor and they ask me the same 6 background questions that I've gotten every other time I've gone. So hopefully those are recorded somewhere. And they can ask me if my place of birth changed since I was here last. That's fine. But not where it was. So the before would be that there would be more in the medical record already there. During, that they wouldn't feel like there's a time limit. And you got to say everything really, really fast because they're going to have to go to the next person. And the after, that's a good question.
How about thanks for coming?
Yeah. I mean, the problem with technology in terms of your time is You know, we've lived in a society where every technological advancement was supposed to save us time, and all it's really done is make us busier and busier and busier. And the washing machine was supposed to be a life-changing experience. I don't know about you guys, but yes, I can wash my clothes faster, but it still takes 2 weeks to fold. You know, and you go back a ways, and their science fiction was that they were going to implant each of us with a little wearable device so they could track where we were, and everybody was like, oh, that's really frightening. Except now, we do it completely voluntarily, and this thing can beep and tell me I haven't checked my email, or I haven't taken my own medication, or whatever. And so it's supposed to help us, but we have a tendency to let it run away. And so I think there's a lot, both of these guys have already mentioned, there's lots of ways in which AI and technologies can help the doctor be more patient, have more patient time, and be more empathetic, and spend less time on the administrative crap. But whether that's then going to turn around and make Kaiser think that you would see more patients in less time would be the thing that we would maybe have to get Congress involved in. I don't know. Right? Something's going to have to prevent that technology from making it worse rather than better in terms of time management.
I would add, I would agree with everything Robin said. I would just add a couple of observations I've seen over the years visiting doctors. I've seen the worst kind of medical encounters with doctors go when they're just typing on the keyboard, listening to what I say and typing it into their chart and I sympathize with where they're coming from. They have 15 minutes, they have to write a note and chart this thing. And then AI can help right there. AI can if AI can record the encounter and transcribe it, well then the doctor can sit and talk to me about how things are going, watch me while I'm talking to them, right? So that would be a big change when it comes, and I hope it comes soon, right? So that would be an example. The other things are like if a doctor orders a test from one lab, but then that's inconvenient, I go somewhere else, then they just can't find it. Medical systems just don't talk to each other, and it's an annoying thing for patients, and I'm like, couldn't they fix it? But they have an incentive not to fix it. So again, I really hope AI makes systems more interoperable, and there's some hope for that, but we never know. At least those are two minor annoyances that I feel AI should hopefully take care of and make life better for someone like me.
I'm just going to say two things briefly for 2037. One is pretty close to what Sriram was saying. I think it would be great if especially when one's seeing a specialist where they're usually looking at one aspect of you, if they had in front of them a full picture of your medical health and health care and all of that. And that's rare these days, and it could happen. The other one is personal. By 2037, I'll be edging into my upper 80s, so I would simply like to be able to still be around to go to the doctor.
Anybody else have a comment about what the ideal, in my mind, you'd probably they'd have your genetic profile as long as it's not shared, and they would say, okay, you were born at the same place, right? And based on that environmental exposure of where you were born and where you've lived, and you ate dinner here and presented with an electronic microphone in your face, you have a X% chance, and then it kind of guides you through that personalized precision medicine. I think that's what everyone's talking about these days.
Exactly.
And that's the whole concept. And I don't know if anybody in this room is going to cry if we don't have to write another note. Yeah. But if we could just say order the antibiotic and have it sent to the pharmacy and done, walk out to the next patient. If we didn't have to touch a keyboard, I think every doctor in this world would shout.
Yeah.
Go ahead.
I was just going to say, when the pandemic was coming up, it turned out that Google could predict regions that were about to break out into hotspots based on when people started querying for why their candle didn't have any smell anymore. right? So there are some like really subtle hidden things that would still be really cool.
Okay, well, that's it. That's the end of the questions. Last 20 minutes. Big round of applause for everybody. Really appreciate everyone coming. Louise, thank you for setting this up. Shiva, who's been recording this. This will be on the website for those that couldn't attend. You can tell your colleagues. And yeah, hope you had a good day. If you have any other suggestions for these types of events, these types of evenings, let us know. Go to the website and send us an email. Thank you all. Be well.